Okay, so quadrilateral ABCD has diagonals AC and BD, which information is not sufficient. So not sufficient, not sufficient to prove that ABCD is a parallelogram. All right, so I'm going to draw myself just a picture of a parallelogram. I usually draw the same one every single time. Just keeps my brain all right. We've got diagonals, they say. Okay, I apologize for my figures here. Okay, so do AC and BD bisect each other? Oh, I know that that's true. So that's, but is that sufficient to prove that it is a parallelogram? Well, no. All right. Or well, yes. Ugh, so not sufficient, sorry. Yes. So AB congruent to CD. Okay, yep. And BC, oops, I should do 3 there. Congruent to AD. Can you prove a parallelogram that way? Opposite sides are congruent. Yeah, that's the that's one of the definitions, right? One of the properties. So that's true. AB congruent to CD and AB, same pair of sides, congruent or parallel to CD. So AB, CD congruent, and AB, CD parallel, right? So that would work too. AB congruent to CD and BC parallel to AD. That doesn't work, having the opposite pairs. So this would be false. That is not enough information. So choice 4. You can prove that the same pair is congruent and parallel, but then the different pairs being congruent and parallel are not sufficient. All right, so 14 is equation of a circle. There's a couple ways to do this. I'm actually going to show you something on the calculator too. Very quickly, what this intends for you to do is use complete the square. Complete the square is not going to exit your life anytime soon. It was there in algebra, it's here in geometry, and it will continue to be in your life in algebra too, so just get used to it. What you want to do is you kind of want to give yourself some space between the x group and the y group and leave that 7 where it is. So I've got all these like spaces in there. We're going to complete the square with the x group. Well, the x group doesn't have like a b term, or what we would consider like the linear term, so I don't have anything to add to that. It's already really a perfect square itself, so I'm all set. I'm going to have to take this 6, and we take the 6 and we divide it by 2. So 6 divided by 2, and we square it. So 6 over 2 is 3, squared is 9. So we're going to add 9 to the left, and if you learned anything in 7th grade, it's to balance your equations, so add it on the right. Now I need to factor this part. I've got the x squared from here, but then this should be a perfect square binomial. So y, and then what 2 numbers multiply to be 9 and sum to be 6? Well, positive 3 and positive 3. So plus 3 plus 3. 7 and 9 make 16. So the center of this circle is 0 because there's nothing with the x. Change the sign of what's in the parentheses here, so negative 3. And then this number right here, this 16, that is r squared. So that means r is the square root of 16, which is 4. So a radius of 4 and a center of 0, negative 3 would be choice 2. Now don't go away, I'm going to show you something awesome on the calculator. So if you go to your calculator, you go to your graph. In here, you can't just type in the equation of a circle. So press menu and scroll down to, oops, graph entry edit. And you see the one that looks like a circle? Choose that. You can type in a line in a weird way, so the 2x plus 3y equals 7, you can type that in. You can type in a circle. Whoops, a circle. Oh, okay, apparently I'm going fast and I can only skip to those 2. So you can type in a circle. Oh, there it goes. All right. Our circle right now is in center radius form, but before that, it was in this form. So before that, in front of the x squared was the number 1. There was nothing with an x there. So then I had y squared plus 6y. Oops, I'm too far. There was no 0x. There was a 6y. And then there was no constant. So I would actually have to bring over the 7. So minus 7, negative, oops, negative 7. I need the negative symbol, excuse me. Negative 7. And I can press enter. And it gives me the circle. Now here's the awesome thing. You can see the center right there. Can you see it? Can you see it? Can you see it? 0, negative 3. Oh, what's the radius? 1, 2, 3, 4. Nailed it. You can get it right with actually not knowing how to do anything but use your calculator, which is awesome. Okay. Yay. So twice two different ways. Oops. Triangles ABC and DEF are drawn below. Great. We've got to label some things, and it asks which statement is true. Now, it's asking if they're congruent, if the angles are congruent, maybe some similarity, and I see proportions there. So I'm going to guess that this is a similarity question. So what I'm actually going to do is I'm going to redraw triangle DEF in the same orientation as ABC. So I'm going to redraw it looking the same direction and orientation. Maybe not a perfect picture, but D is here. E matches with B, and F matches with C. It's a terrible triangle. I'm aware of that. Okay, so A to B is 9. B to C is 15. D to E is 6. E to F is 10. And the angle B is congruent to angle E. So E and B are congruent. All right. Which statement is true? Well, just looking at this and knowing that these triangles are most likely similar, I'm thinking side, angle, side, similarity. And so I can look down here. Is angle CAB, this angle, congruent to angle DEF, this angle? Well, no, because E and B are the same, so that's not it. Is triangle ABC similar to DEF? Well, if those sides are in proportion, I'm going to guess so. So is 9 over 6 equal to 15 over 10? Now I'm going to show you how to use the calculator to help you with that. So go here, go to your calculator, go here. What is it, 9 over 6? So let me do Doc B really quickly. Control divide. Is 9 over 6, that was good, 9 over 6, equal to, what did we say, 15 over 10 or 10 over 15? Now I can't remember, it's too far away. 15 over 10, whoops. Control divide. 15 over 10. That's true. So that means the sides are in proportion. So that means that the triangles are similar because we have the sides in proportion and a congruent angle. Let me just minimize this really quickly. All right, so yeah, they are similar. All right, I don't even have to go through the proportions. I'm going to guess that they're wrong though. AB compared to CB is the same thing as FE compared to DE. No, that's exactly backwards. AB and DE, that matches. Yep, that's right. And then FE is exactly backwards. We'd have to use the same triangle again. All right, so dilation. Dilated by a scale factor of 3. Which statement is true? The big deal here is the dilation. Dilated by a scale factor of 3. I hope you're laughing at that. Okay. So they're telling me triangle ABC is dilated, D3, right? A dilation of 3. So to become triangle A prime, B prime, C prime. Well, that means that this triangle is 3 times, that's an M, that triangle. So triangle A prime, B prime, C prime is 3 times the size of triangle ABC. Okay, which of the following says that? 3A prime, B prime is equal to AB. Oh, no, that's exactly opposite, so no. B prime, C prime is 3 times BC. Yeah, can you see that? B prime, C prime is 3 times BC. So it's got to be that. Let's talk about why it's not 3 and 4. This is a big deal. In a dilation, the triangles are similar, so the angle sizes don't change. The angles are congruent. So I could have eliminated those in the very beginning. Okay, so Steve drew line segments, ABCD, blah, 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 blah. Scalene triangle A, BFC is formed. Which statement will allow Steve to prove parallel lines? Okay, parallel lines. When I see parallel lines, I think alternate interior, alternate exterior, corresponding, right? Those are the big ones. So right away, I'm looking around. Okay, so CFG is this angle out here, congruent to FCB, that angle here. Are those alternate interior, alternate exterior, or corresponding? Yeah, those are alternate interior angles. And if alternate interior angles are congruent, then the 2 lines are parallel. So it's actually choice 1. Let's talk about why it's not the other choices. ABF is, let me get a different color. ABF is this one. And BFC is inside the triangle. Those look like they're almost alternate interior, but they're not, because F doesn't stretch all the way to the horizontal part. It's missing that little extra blue piece that I'm trying to color in. Okay, so that's not it. EFB, that's going to be, I'll use red for that. EFB is this one. And CFB, again, okay, well, those are just next to each other, and they're not even a linear pair because, well, we would need this part. So that's not it. And then CBF. I'll use yellow highlighter because apparently it wants me to use that. CBF is that little guy. And then GFC is that little guy. They're not even talking about the same transversal, so they're out too. So it has to be choice 1 for sure. All right, so then we've got this question. This will make you crazy if you don't know one fun fact. So in the diagram below, CD is the image of AB after a dilation of scale factor K with center E. So CD, this is the image. CD is the image. Okay? So let me get this, and I just gotta get rid of this. I'm sorry, it's just making me crazy. All right. This is the image. And this is the pre-image. Okay, so we are dilating it. Which ratio is equal to the scale factor K? So what we actually have to figure out is we have to know that it's image over pre-image. Right? And I'm actually going to connect these to the, oh, I bet I could use the drawing tool. Let's see if I can use these straight lines today. Let's just, oh, bananas. But they're in highlighter. Let's undo that. Okay, sorry. I'm going to try to draw those lines for you because we're going to need them. My fine motor skills are not quite cooperating. Oh my word. Draw. Drawing tool. This one. Okay, well, this is annoying, so I'm going to do my best here. Let's undo that big black mark because that was just absurd. And we're going to try to connect these in the straightest line possible because I can't get my drawing tools to work. All right, let's pretend that those are straight lines and that I'm doing a good job with those. Okay, so which is equal to the scale factor of K? The scale factor is equal to the image over the pre-image. So the image is EC part of the image, E to C. Yes. Okay. Is E to A part of the pre-image? Oh, yeah, it is. So this is actually going to be choice 1 again. Now let's talk about why they aren't the other choices. BA is the pre-image over EA. Those don't even match. That's completely wrong. Those are both parts of the image, so it's not 2. EA is that right-hand side over BA. Same deal, just flipped. Okay, just flipped here. And then EA is the image over EC. Did I say that wrong? Image, EA. Oh, no, EA is the pre-image, sorry. Pre-image over the image. So, yeah, image over pre-image is important to your life. It has to be choice 1. So if you know that image over pre-image is the scale factor, that would be essential to your life. Okay. All right, so we've got a gallon of paint to cover approximately 450 square feet. Okay, this, as soon as I see square feet, it's some kind of area. All right, you have to know the area is in square feet. An artist wants to paint all the outside surfaces of a cube, measuring 12 feet on each edge. The fun fact that you need to know about a cube is that all the sides are the same. So let me try this drawing tool just one more time. I promise that I'm not a lunatic here. I thought that there was 3D shapes and that I could just use them. Shapes. No. Okay, just kidding. So I'm going to draw a cube to the best of my drawing abilities. There's my cube. All sides of a cube are congruent. So it's a type of rectangular prism, but it's like the square rectangular prism. So 12, 12, 12. All right, so the volume, or not the volume, they don't want volume, they want area. So what they actually want is surface area. A cube has 6 sides. It's easier for me to use cursive. Each of those 6 sides is 12, right? 12 by 12. So each of those 6 sides has an area of 144 square feet. So I have 144 times the 6 sides should be equal to 864 is my surface area. So surface area is 864. All right. What is the least number of gallons of paint he must buy to paint the cube? Well, 1 can covers 450 square feet. So I take my 864 square feet and I think to myself, okay, well, 1 would be only 450, but 2 times 450 is 900. Can I buy a half of a can of paint? Right? Yeah, technically, yes, you could get like a smaller container, but they're saying of the 450 type. So what we're actually doing is dividing by 450 and getting 1.92 gallons. You can't go to the store and say you want 0.92 of a gallon of paint. They're going to giggle at you. It would mean that you need 2 full gallons of paint to get the job done. So choice 2. 20, we've got the circle. Oh, there's all kinds of stuff going on here. All right, we've got a diameter. It's perpendicular to CD, meaning that CD is a tangent line, so this is perpendicular. At point C. Chords A, B, B, C, A, E, and E, F are shown. Okay, which is not always true. I feel like the theme of this test is which is false, which is not true, which is not sufficient, right? I feel like that's the general theme here, and that's really annoying. So be careful of that. I would highlight or circle those words anytime you see them. Okay, what do we have here? We need to know that those are perpendicular. The other thing you actually need to spot here is that A to C is a diameter. And if you see a triangle, ABC, inscribed in a semicircle, you have to know that that means that's a right triangle. The other way to think about it is use one of your circle theorems. A to C, that whole arc, is 180 degrees. B is half of that arc, 90 degrees. The same is the same is true over here. AEC holds the diameter, so angle E is also 90 degrees. That's a really big deal to know that. So which statement is not always true? ACB is this piece here, congruent to BCD. Oh yeah, no, that's not always true. They don't always bisect. So that's it. It's always choice one too. Don't think that that's a thing, by the way. ABC is congruent to ACD. ABC, ACD, both right angles. Okay, that's true. BAC is congruent to DCB. Oh, that's actually a good question, or a good point to make. This one is on the opposite side of the circle, holding arc BC. And this angle is on the circle, holding arc BC. So they're congruent. All right, so that's true. And CBA is a right angle, and AEC is also a right angle, so that is also true. So yeah, it's definitely choice one. I would, on the Regents, go through your choices there. Make sure you didn't do something silly like switch around a letter in your head or something wacky like that. All right, another similar triangle question. I hope you're getting the idea that similar triangles and congruent triangles are kind of a big deal. If AC is 12, DC is 7, DE is 5, the perimeter of ABC is 30, what is the perimeter of DEC? One thing that you do need to know, if they're telling us that the triangles are similar, that the perimeters have the same ratio as the sides. Okay, so that's actually really nice. So let's see, I'm going to redraw this triangle, DEC, to line up. So A matches with D, B matches with E, and C matches with itself. I know my triangle is not perfect, but that's okay. So then they tell me that A to C is 12, D to C is 7, so those two sides are being compared. D to E is 5, so the side I would normally compare with would be AB. The perimeter of triangle ABC, this perimeter is 30. We want to find the perimeter of this triangle. So I can use a side ratio and then just set the perimeters in the same ratio. So I'm going to use 12 is to 7, so 12 over 7 is equal to perimeter of ABC, 30, over perimeter of DEC, which I need to solve for. Favorite thing in the whole world, cross multiply. 12p is equal to 210. Divide by 12. And p is equal to 17.5. So choice 4. Oh my word. Okay, so we have a line 3y. It's not in y equals mx plus b form. Let it go. Let it go. Let it go. No, I won't sing. I'm sorry. It's transformed by dilation. Oh my word. Have we seen that like 3 or 4 times? Centered at the origin, which linear equation could be its image? Big deal that you need to know is that the slope in a dilation does not change. Only the y-intercept changes. Yay! So let's rewrite this line to figure out its slope. So we would have to divide by 3 on both sides, and we would get y equals negative 2x over 3 plus 8 over 3. Okay. Which linear equation could be its image? Whichever one has a slope of negative 2/3 is going to be its image. So I'm going to just start moving some stuff around here. Let's see. Let's go with these choices. Let's see. This one I'll have to subtract the 2x. This one I'll have to subtract the 2x. So those look like possibilities. These don't even have a 2x, so I'm going to guess that it's not 3 or 4. So 2x plus 3y equals 5. I'm going to subtract the 2x and leave it in the right order. Divide by 3, divide by 3. Okay. Y is equal to negative 2/3 x plus 5/3. Does that have the same slope? Yeah. Okay. Let me show you something cool on the calculator too. So I'm going to go to my fancy calculator. I'm going to go to this. I showed you how to enter the circle, right? So we're going to go to Graph Entry Edit. So Menu 3. And we are going to type in an equation template. Whoops. Of a line. Not in mx plus b, but in this kind. ax plus by equals c. So all of my choices here, and the first one isn't that way, but 2x plus 3y equals 5. I'm going to graph that. And I'm also going to graph, and let me do another one. I'm going to graph choice 2. 2x, and if it's minus 3y, you do a negative. So negative 3 equals 5. Okay, so you have those two lines, right? Our original line was, when we graphed it, tab, would be, let's see, positive 2x, positive 3y equals 8. Which pair of those look parallel? The black and the blue, right? So the black is our original, and the blue is choice 1, the red is choice 2. So you can actually see that graphically if you'd like. All right, let's talk about 23. A circle with a radius of 5 was divided into 24 congruent sectors. So they cut it up like a pie, but made the smallest pieces of pie ever. The sectors were then rearranged as shown in the diagram below. To the nearest integer, what is the value of x? All right, so as you can see, we take this circle, this beautiful circle, and we split it in half, right? Cutting it in half. So this is half of the circle, and this is half of the circle. So this length is half of the length around the outside of the circle, right? Also known as half of the circumference. X is equal to half of, and our circumference formula is 2 pi r. They told me that the radius times 2 times pi, they told me that the radius was 5. I hope you know that 1/2 times 2 is 1. So 5 pi, let's figure out what that is. 5 pi. 5, and then the pi symbol is down here in this little menu. 15.707. So 15.707 is closest to 16. So it's got to be choice. Oh, am I upside down? I am. Sorry. I'm trying to write with an eraser. How's that going to go? Choice 2. Okay, so last question, last multiple choice, and it usually can be the hardest question if the state writes the test correctly, but that's no promise. Which statement is sufficient? So we have one that's a not, is sufficient evidence to prove that the triangles are congruent. Okay, that's great. AB is equal to DE, BC is equal to EF. That would just be side. That's not a congruence theorem. No. Angle. Is that a congruence theorem? No, that is a similarity theorem. There is a sequence of rigid motions that map AB onto DE. Okay, AB, DE, that's okay. BC onto EF, that's okay. And AC onto DF. Okay, rigid motions, and that was all sides. So 3 sets of sides congruent, side. Is that a congruence theorem? Yeah, that is. So let's circle that, but let's check out choice 4 just in case. There is a sequence of rigid motions that map point A, onto point D. Is that any part of a congruence theorem? No. We're gonna skip that. Okay. So it's got to be choice 3. Yay! We are done with multiple choice. On to part 2, where you have to show all of your work and can't really use calculator tricks.